Welcome to the overview tutorial for the gravity engine asset. The goal of this tutorial is to show you how to quickly build a scene like this, where we have a central star, a planet in an eccentric orbit, and a ring of particles all interacting gravitationally under the control of the gravity engine. Other tutorials will go into more of the details of each of these elements, but this is a quick start tutorial to show you how to put something like this together. Let's stop this scene and create a new one. And the first thing we need to do is add a gravity engine to this scene. To make that easy, it's available in the 3D object menu. We then need to add a star and a planet. We'll begin by creating an empty game object. We will call this star. And then we will add to this an n-body component. The way we specify that a body is under the control of the gravity engine and indicate the mass and initial velocity of that body is by adding an n-body component. So you can see we've got an n-body script. We can provide a mass, so we'll make the star, say, 1,000, make it fairly heavy. And you can notice also that the transform has changed to just show you the position, and that's because the gravity engine will be in charge of the position of this object. We'll create a model that will be the physical model of the star, so we'll call this star model. It's just a 3D sphere. We'll make it a child of the star, and we'll make it a little bit bigger, and then we will go into our materials and give it a bit of texture using the solar texture. The reason we don't attach the sphere direct, or make the sphere a direct element of the star, has to do with the way the scaling works when we begin to add planets, because we'll add planets as children of the star, and we want their positions to stay under the control of the gravity engine, and if we were to scale the star, things wouldn't work out properly. So we make the physical representation of the star a child of the n-body object that represents the star. The prefabs will do this for you automatically, but here we're going to build everything from the ground up. So now we need a planet, so we'll create another 3D object. Sorry, game object. Call it planet. We will once again add a sphere as a child. And we'll pick this representation of Ganymede. And we need to make our planet an n-body, so we'll do that part. We'll give our planet a small amount of mass. Now we want our planet to orbit the star, so we want to add a component that will correctly initialize the velocity to provide the orbit we've looked for. So we add this orbit ellipse component. An orbit ellipse looks for a parent around which to orbit, so we now make the planet a child of the star. And then we can say, let's have an orbit that's 10 units big, and what we see in the inspector automatically is a representation of the orbit. And we can now change the eccentricity of the orbit, control the other orbital parameters, the orientation of the ellipse, the inclination of the ellipse. And these parameters, the 2 omegas and the inclination, are essentially just Euler angles, but they're the conventional Euler angles for describing an elliptical orbit. And at this point, if we press play, we see the planet in orbit. Let's move our camera out a little bit. And get rid of the skybox. Let's have a dark sky. We can have a look again. Now we have a planet moving around the sun. These are interacting gravitationally. To create a dust ring, as we had in the previous example. We'll create a game object, call it dust ring. We will add to this a particle system. And we want the particles in the dust ring to be static, so we don't need looping. We want them to be fairly long-lived. Speed of the particles will be under control of the gravity engine script dust ring we add, and we don't want to emit particles. What we want is to create them all at the beginning, so we'll make a burst of 1,000 particles. Now we need to make these particles move under the influence of gravity, which we do by adding a gravity particle script. And we want them to be initialized in the shape of a ring orbiting around the star, so we add an additional script called dust ring. And we take this and we make it a child of the star so that we know where the ring will be. And in this case, we'll make the ring at a radius of 13, and we'll make the width about 10% of the radius so that it has a little bit of physical extent. Now, if we want the particles to be seen, we'll add a bit of a material there, and then we'll go ahead and press play. Now we have our dust ring, we have the planet moving in an eccentric orbit, disrupting the particles. And we have a fairly pleasing gravitationally accurate effect. The only thing missing from the first example I showed was the star field in the background. So to create that, we can just add a particle system. Again, we don't want it looping, we want it long-lived. We want to emit in a burst. We want to emit in a hemisphere. We want a radius of, say, 100. We can either have them as a shell or filling out space. And we want the orientation as zeros. And then when we press play, now we have our star field. We have the star field moving a little bit because we didn't set the lifetime to 999 and the speed to 0, and now we'll get a static star field. Now we have created the quick tutorial scene. There's a lot more we can do with the gravity engine, and in a number of the other tutorials we'll look at the attributes of the gravity engine, the way in which we can do hierarchical systems, binary stars, and lots of other cool things. Thanks for listening.